Hey, okay, today we are going to look at the natural log, or as your calculator will say, ln. So the natural log, ln's probably for log, naturel, it's French. Okay, so there's a base that's extremely common, and it is e. Now, e is just a number. It's an irrational number. It's just like pi, and it equals 2.718, yada, yada, yada. It's an irrational number, so we often just refer to it as 2.7 or 2.72. It is one of those numbers that's so useful. It pops up a lot in anything that has growth. So we see it a lot in nature and finance. It's really common. So if we're looking for the log base e of any number, like, I don't know, 83, this is what we're basically asking you. Let's say that equals x. What we're really asking is e to the what equals 83. Well, that's the same as saying like 2.7 to the what equals 83. And I don't know. So you can put that in your calculator. Now, the log base e is so common that it gets its own name. When you take a logarithm with the base of e, we refer to that as the natural log. So this is the same as writing ln 83 equals x. This is the exact same thing. That ln represents a logarithm with a base of e. So same deal. We can still rewrite that as e to the x equals 83. It's just the natural log. So let's look at some examples of this. If we have the natural log of 1, well, what's that going to be? So what we're going to do is we're going to think about this for a second. Remember, this is log base e of 1 equals x. So then you're like, okay, e to the what equals 1. Well, x has to be 0, right? Anything to the 0 equals 1. So x equals 0. That's just a quick example. What if we do something like this? Okay, let's keep track here. Let's do example 2. What if we have the natural log of e? What does that equal? Well, all right, so we'll call this x. So if we put this in log format, we have log base e of e equals x. Okay, move it to exponential. E to the x equals e. So x is 1, right? See how this works? All right, what if we have something like this? What if we have like 3e squared? I want to know what that means. This is just a value. This is just a number. E is not a variable, right? E is not a variable. This is like saying, what is 3 times 2.7 squared? Well, use your calculator. What is it? It's like 22.17-ish. Okay, what if you have something like this? What if you're asked to evaluate? Remember, evaluate just means like crunch your numbers. If you've got ln 2, so this is the natural log of 2, is how we would say that. Again, there's no variable here. You're just putting this in your calculator. So you're going to find in your calculator ln. It might be the second function of log. It might have its own button. It depends on what you're doing. And you're just going to push natural log of 2. So either ln 2, or maybe you need to push 2 ln. And it's going to give you a number. This is a value. This is like 0.69, 0.7, I think. Okay, let's be a little more tricky. What if we have the natural log of 1/2? Okay, let's think about this. If we wanted to solve this, half is, I don't know, how can we rewrite that? What if we rewrote this as the natural log of 2 to the negative 1? And then what if we use power law? We have negative 1 times the natural log of 2. Okay, again, making life a little bit easier. This is going to be negative 0.7, right? Didn't we just solve that up here? Okay, how about this? What is the natural log of e to the fourth? Think about this for a second. Use power rule. This is 4 times the natural log of e. The natural log of e is 4 times log base e to the e, right? This is really 4 times 1, which is 4. Cool, huh? So, if you're looking at your notes, we're down here at number 7. So if you're given something and you're asked to write it in exponential form, so if you're giving a log, a natural log, and asked to write it in exponential form, you are simply going to put it as a log base e, and from there, you're going to do your loop-de-loop and rewrite e to the something equals 1. All right? Very simple. What if we've got something a little bit more complex? What if we've got the natural log of 9 equals 2.2, and you're asked to convert this to exponential form? Same deal. Log base e of 9 equals 2.2. Once you've turned it in to a log base e, from there you can convert to exponential and you get e to the 2.2 equals 9, right? What if we're going in reverse direction? What if you're asked to put in log form? What if you're given an exponent? What if you're given e cubed equals 22.09? If this is going to go into log form, you're going to say, okay, log base e of 22.09 equals 3. But don't leave it with a log base e. Keep going. That's the natural log of 22.09 equals 3. Right? Okay, one last example. What if you have e to the 1/3 equals 1.4? Then you want to put that in log form. Okay, log base e of 1.4 equals 1/3. Remember, rewrite your log base e as the natural log of 1.4 equals 1/3. Okay, so all rules apply with natural logs. Like if you've got the natural log of x squared y, and you're asked to expand that, you can use your log laws. So you can expand this to the natural log of x squared plus the natural log of y. Then use your power law, so 2 times the natural log of x plus the natural log of y. All rules apply. It's just a log, right? Keep that in mind. It's just a log with a base of e, which is 2.7. So all the log rules apply. Everything you've been doing, you'll keep doing. Same with its graph. It all keeps going. Okay, I hope that made sense. Yeah, okay, good luck.